This is how to connect an Arduino Uno to a rotary encoder. And this is a Waveshare Rotary Encoder. It comes with this set of leads as well, but because they are female on the end, I changed them out just for regular jumper leads with female to male. So the rotary encoder is different to a potentiometer, just to make sure you know that. This has a certain number of pulses per rotation. So if I move it closer to the microphone, you might be able to hear it clicking. Can you hear that? That was the clicking of when I was rotating this around. So this particular rotary encoder has 20 pulses per revolution, which means that one entire revolution of 360 degrees results in 20 rotations. So that means that it has a resolution of 18 degrees. So to connect this, if you have a different rotary encoder, you might have different names on the module. Here we have VCC, ground, SW, SIB, and SIA. So the SIB and SIA might be data and clock for your one, but it's the exact same kind of thing. So the VCC, that's the first on the left here, that goes to the 5 volts in the Arduino, just to show you that there. Then the ground goes to the ground on the Arduino. Then the SW, that's the blue cable, that goes to pin 3. Then the SIB, which is green, that goes to 4. If whatever that's called for your rotary encoder, if that's data, then connect that as well to number 4. Then SIA is the yellow one, and that goes to number 5 in the digital pins for the Arduino. So that is how to connect your rotary encoder. Let's go to the code now. So we're going to use the code from this page. The link to it is in the description below. It's a really nice tutorial. And if we come down, we can see that they're using a rotary encoder and they have the SIB pin labeled DT because that's what they have in their rotary encoder, and the SIA pin labeled as CLK, so the clock. Now, go into Arduino and we need to download one library. It's called Button Feeder. So just go to Tools, Manage Libraries, and then type in BF Button and install this one. Once you have it installed, you can then copy the code from the first example here and paste it into your Arduino file here. So let's go through what this code is doing. First of all, we have the library being called. Then we are declaring 3 integers, button pin. So this rotary encoder, as a lot of rotary encoders have, a button. So looking at this particular case, that comes from SW, and that's the same for the Waveshare Rotary Encoder as well. The SW pin is for the button. So if you actually push this down, then it will start to click. And in this library, we've actually got some special functions for it, which we'll go through in a second. But first of all, bottom pin is 3, that's SW. Then here they say DT equals 4, which is our SIB for our Waveshare Rotary Encoder. Then SIA is 5, and that's the clock here, 5. Then for the button, they're declaring this in their library, the function that, okay, there is a button. It's the button pin. And first of all, it's on. And secondly, we've set it to low, so it's not engaged. Then we have a few more integers being declared: counter, angle, A state, A last state. These we'll figure out later what they are once we come to the void loop. Let's now go to this function here. So we have 3 different ways that we can press this button on the rotary encoder. We have a single press where you just press it once, double press where you click it twice in succession very quickly, then long press where we hold it, we press it and we hold it for an extended period, and then the serial monitor will print whether we've done single push, double push, or long push. Then let's actually quickly show you what that looks like. So if I press single, double push, and then long push there. So that's what that will come out to be. So now in the void setup, we have serial begin, 9600 baud rate. We're printing the angle. Then the pin modes, we're saying that the clock and DT, which is our SIA and SIB respectively, they are pull-ups, so we're reading the data from these pins. And then the last state is the reading of the CLK. So that's SIA for us. That's important because that will tell Arduino later on whether the rotary encoder has rotated or not. Then for the button, we just have a few settings for that. We have the timeout. You can make this longer if you want to have the long press change, whatever. Anyway, in the void loop, this is where when we go to the serial monitor, we'll be able to rotate the rotary encoder and we'll be able to see how it changes. How does it do that with this code? So first of all, it reads the button. if it's being pressed or not. Then we come to A state. So A state equals the reading of CLK, so SIA for us. Remember that we also set that to be a last state in our void setup. That was the initialization of it. Now we're saying A state is this. The reason why we want to have two different variables, A state and A last state, is in this next part here, we're telling Arduino if A state doesn't equal A last state, well, now actually something has changed. The button has rotated. So if it hasn't changed, so if this A state equals A last state, then what we have here from here to here won't be activated, and we won't have anything being printed. And I'll show you that now. When we open up the serial monitor, I'm not changing anything on the rotary encoder, I'm not touching it, and you can see that the serial monitor isn't printing anything other than that initial 0. That rotary encoder, it was at 0 when I opened the serial monitor. It still is, because I haven't pressed it, I haven't rotated it, I haven't done anything to it. That's because this requirement has not been satisfied. A state still equals A last state. If on the other hand, I rotate it now, 1, or whatever, how much you want, then CLK will be different. So A state will not equal A last state. So we'll now call this piece of the code here. So now we go to the if statement here. If digital read DT doesn't equal A last state, so in other words, what we are getting out of the 4th pin SIB for us, if that doesn't equal the clock, then we are going to say that the counter is going to increase by 1. So that means that that's the positive value. And what I mean by that is if we open up the serial monitor and I rotate this, you can see it's going negative. The other way is positive. So that's saying that if DT doesn't equal A last state, then this way is positive. If it does equal A last state, then it means that we're going in the negative direction. So if you have your rotary encoder and you wanted to have a certain direction being positive and you turn it in the serial monitor and you find out it's negative, you have two options. One, you can either change the leads of SIA and SIB, just swap them in your Arduino. So SIA, which is now going to 5, is actually going to 4, and SIB, which is now going to 4, goes to 5 instead. That will then switch this sign here. Or you can just come to the code and change this to negative, and positive. This one should be positive 2. That will then just switch the direction. So you have the sign that you want. Now, this next part of the code, what we are doing here is we're saying that the counter can only go up to 100 rotation, up to 100 pulses. This is a 20 pulse per revolution rotary encoder. So that 100 means that we actually have 5 rotations. 100 divided by 20 is 5. And what that means is if I open up the serial monitor, I continually rotate this around. You can see it goes negative. It's all good. It's counting up to negative 100. And now it just maxes out. That's saying that we only go to 5 rotations in total. And likewise, here it says if it goes past plus 100, then we only count that as 100 anyway. So we're not saying we can go up to like 1,000 or whatever. It's only 100. That's the maximum and nothing more. If you want to change that, all you do is you can literally just comment this out. If you like, you can just do that. And now this will just count forever. You can go up to 1,000, 1,000,000, whatever you like. Or if you want to have a different limit, you can then put a different number here. So you can do 500, 500, whatever you like. And then finally, it just prints out what the rotary encoder is at. So we start off at 0, and now I'm rotating it a bit. It's at 34, and so on and so forth. So that is how you use the rotary encoder with Arduino.